Hello, good afternoon friends. Today we discuss about the reduction by using dissolving metals in a solvent. So in that we discuss about the sodium in alcohol, sodium in liquid ammonia, then by magnesium, then by zinc in HCl or zinc in acetic acid, then Sn in HCl or iron in HCl. By using this metal in a solvent we use for the reductions of different compounds. So let's see first the reduction by using sodium in alcohol. Now this sodium in alcohol are used for the reductions of ester to alcohol. So this reaction is also called as the Bouvet-Blanc reaction, Bouvet-Blanc reactions in which the ester get reduced to alcohol. So let's see the reactions of Bouvet-Blanc reactions. So Bouvet-Blanc reductions. In the Bouvet-Blanc reactions, the ester group get reduced to, in presence of sodium in EtOH, it gives RCH2OH. Plus, if there is ester R dash, it becomes R dash OH. So the primary alcohol formation takes place from the ester. So let's see the mechanism of this reaction. RC double bond O R dash. Now sodium transfer the electron to the carbonyl, then there is O minus. So there is formation of RCO minus OR, and here is a radical. Then there is another protonation of this O minus by EtOH, ethyl alcohol. It takes proton, it becomes RCOH and OR dash. So there is a radical. Then there is transfer of another electron from the sodium, and there is RCOH HOR dash. So this protonation by EtOH. So there is one radical is transferred, there is formation of carbanium, and carbanium attack on carbanium takes the proton from the alcohol from the protonated this product. Then again there is migration of this electron from here to here. There is formation of C double bond O, and OR minus with the proton, it lost as a minus ROH alcohol, and there is formation of RC double bond OH aldehyde. Again the aldehyde get reduced by using sodium and transfer electron. Then there is O minus RCO minus H electron, and again by protonation EtOH. Then there is formation of RCOH H radical. Again another sodium transfer radical. There is formation of RCOH negative charge H, and this negative charge again protonation by EtOH ethyl alcohol, it gives RCH2OH. That is primary alcohol is obtained from the reduction of ester by using these Bouvet-Blanc reduction reactions. Another examples, let's see the more examples of the reaction. COOH COOAT. In presence of sodium in ETOH, ethyl alcohol, it gives ester gives alcohol. So there is formation of this product CH2OH, CH2OH. So these two alcohol formation take place, and if the same reaction is carried out in presence of sodium in a protic solvent, that is in xylene, then the reaction is Asylum condensation reactions, and in the Asylum condensation reaction there is formation of this Asylum product, Asylum condensation reactions, in which there is a xylene, a protic solvent is used, then Asylum condensation takes place from the same starting material. And here is cobalt blank reduction reaction, and this is the Asylum condensation reaction in presence of a protic solvent. Now let's see more reactions of the sodium in alcohol. The sodium in alcohol are used for the reductions of the ester as well as carboxylamide. Means carboxylamide also reduced by using the sodium in alcohol. So let's see more example reductions of esters. Example PH CH double bond CH COOAT. Here in sodium in alcohol, it reduces carbon-carbon double bond as well as ester to the alcohol. So there is formation of PH CH2 CH2 CH2OH. So this product double bond is also reduced as well as this ester will reduce to primary alcohol. Then more examples of reductions. If there is COOAT and here is a double bond. Now in presence of sodium in ETOH, ethyl alcohol, only the ester group is reduced, and here the carbon-carbon double bond is not reduced because the carbon double bond is not in conjugation with this ester group. Now here this is in conjugation with ester group and therefore it gets reduced. Here the double bond remain as it is, and there is CH2OH formation takes place in presence of sodium in ethanol. Then next, reduction of ketone. The carbonyl compound get reduced to alcohol by using the sodium in alcohol. Now the cyclohexanol is get reduced to cyclohexanol, and there is the hydride. Let's see the example of cyclohexanol of this type. In this, in presence of sodium in ETOH, ethyl alcohol, the electron transfer occurs from the upper side, and therefore there is O minus, and here is electron, and this O minus protonation by using ETOH. HOAT protonation of this OH takes place. There is OH, and again another electron is transferred by sodium to this empty partially filled orbitals, and there is negative charge, means there is two electrons, or we can say there is negative charge. Here is OH, and again protonation in ETOH. This negative charge takes the proton, again protonation. So equatorial OH formation of this equatorial product as a major product take place, means stereospecific reactions by using sodium in alcohol or the cyclohexanol take place. Then next, reductions of nitride. Reduction of nitride to primary amine. So let's see example CN by using sodium in ethyl alcohol, it gives NH2. So nitrile, alkyl nitrile get reduced to primary amide by using the sodium in ethanol. Now reduction of oxime to amine, reduction of oxime by using sodium in ethyl alcohol gives PH and H2. Now this oxime get reduced to amine by using the sodium in ethyl alcohol. Now the reduction of sulfonamide, next reaction by using sodium in ethanol. Sodium in ethanol also reduces the sulfonamide. Let's see the example of sulfonamide. And tosylate this sulfonamide by using sodium in isopentyl alcohol as a solvent, it gives NH, cyclic amide. So this tosylate bond breakdown means sulfonamide get converted to amine in presence of sodium in isopentyl alcohol. Then reduction of aromatic hydrocarbon, reduction of aromatic hydrocarbon OH. So here by using sodium in ETOH, sodium in ethyl alcohol, ethanol, there is reduction of these two bonds take place in presence of sodium in ethanol, and this alcohol is formed from the beta naphthol. Such type of alcohol formation takes place by using sodium in ETOH. Then another example, OET in presence of Na-ethyl alcohol. Again this aromatic ring gets reduced and there is formation of carbonyl compound from this OET take place. Then if there are two separate aromatic ring, then the aromatic ring in which electron withdrawing group is present, COOH, electron withdrawing group is present, then the out of these two rings, the electron withdrawing group is present on this ring. This aromatic ring get reduced by using sodium in alcohol. Sodium in alcohol get reduces the aromatic ring on which electron COOH, electron withdrawing group is present, and OME, the electron donating ring remain as it is. Then another example of aromatic reductions ring by using sodium in alcohol. And so this type of aromatic compounds in presence of sodium in pentyl alcohol, isopentyl C5H11OH, isopentyl alcohol, so there is NH. So this ring, aromatic ring of pyridine moiety, get reduced to the saturated ring system. Then another reductions of alkene. Alkene also get reduced by using the sodium in alcohol. Let's see the example of reduction of alkene. PH3H2OH. So this type of alcohol and double bond. This double bond is reduced by using sodium to form the single bond OH. So double bond get converted to single bond. Then cleavage of ether also take place. Another use of the sodium in alcohol are used for the reduction of NME. So cleavage of ether ring means this ether, aromatic ether, cleavage of this bond take place by using sodium in alcohol. So there is NME. Breaking of this bond, that means ether cleavage is take place by using the sodium in isopropyl alcohol as well as in xylene as a solvent. Okay. Then next, the sodium in alcohol are used for the cleavage of carbon halogen bond. The reduction of carbon halogen bond is carried out by using sodium in alcohol Br. So in presence of sodium in wet methanol MEOH. So there is a reduction of this carbon halogen bond take place and formation of this product occur. Then another example, let's see another example of reduction of carbon halogen bond. OME, Cl, there is also Cl. In presence of Na, tertiary butyl alcohol, and THF, tetrahydroquinone. Now again there are 4 carbon and halogen, that is Cl bond. This all the Cl bond cleavage occur by using sodium OME remain as it is. All this carbon and chlorine bond cleavage take place. So let's see another example. Br double bond by using sodium in alcohol. It also get reduced to form this type of product. Then let's see the second reducing agent, that is sodium in liquid ammonia. Now sodium in liquid ammonia are used for the reduction of alkyne to form the trans-alkene, as well as in the Birch reduction, sodium in liquid ammonia is used. So second reducing agent, sodium in liquid ammonia. So sodium in liquid ammonia are used for the Birch reductions. In Birch reductions, the benzene ring get reduced by using sodium in liquid ammonia to 1,4 reductions take place by using sodium in liquid ammonia, and this 1,4 reduction is called as the Birch reductions. So reductions of benzene at 1,4 position take place by using sodium in liquid ammonia. This reaction is called as the Birch reduction. This reaction is called Birch reduction reactions. Now if there is electron donating group or electron withdrawing group present on the benzene ring, then the radioselectivity occur in the reductions by using sodium in liquid ammonia. The electron donating group present on the unsaturated carbon after the reductions, and electron withdrawing group present on the saturated carbon after the reductions. Let's see the radioselectivity for the reductions. If there is electron donating group, that is OR or OME, methoxy or alkoxy group is present, then by using sodium in liquid ammonia, there is formation of OR. This product formation takes place. Means again there is 1,4 reductions and the electron donating group present on the unsaturated carbon. So how these reactions occur? Let's see the mechanism of this reaction. In the mechanism, again sodium transfer electron, and as the electron donating group, that is, let's see the example of OR. So these are the electron donating group, and as this is electron donating group, there is negative charge at ortho and para position, and therefore electron transfer occur at the meta position. So by using sodium, there is transfer of electron at this position, then this bond shifting here, there is negative charge at ortho position. So OR, negative charge, and here is electron. So there is maximum separation between negative charge spaces and radical, and therefore this is somewhat stable. Now there is protonation by ammonia and H2. So the negative charge takes the proton. There is H or H. OR double bond. There is radical double bond. Again another sodium transfer electron. There is formation of negative charge at this position and OR. So there is an H2 and sodium NH2 removed as soda amide here minus NH2 by abstraction of proton on the ammonia. There is minus NH2, soda amide is lost and the product obtained with 1,4 reductions with OR group present at unsaturated cysteine. So radioselectivity occur by using sodium in liquid ammonia. Selectively, the electron donating group present on the unsaturated carbon, and if there is electron withdrawing group, let's see the example of electron withdrawing group, then what would be the product? If there is electron withdrawing group is present on the benzene ring, let's see the example of COOH. By using sodium in liquid ammonia, here the proton source is the ammonia. Now here these are electron donating group. So there is positive charge at ortho positions, and therefore the electron transfer takes place at this position. Then there is C minus and a transfer of this electron is transferred here, and there is, so as it is electron withdrawing group, this position is electron deficient, so the transfer of electron takes place here, and there is COOH, radical negative charge. Or we say here is a repulsion, therefore this double bond shifting here, and there is negative charge at para position. Yeah, in another way we can transfer electron. See here, in another way we can transfer electron COOH as at the para position. Electron transfer. Again one electron come here, there is formation of negative charge. This electron transfer here, this electron transfer here, there is formation of double bond, and here is formation of radical. So COOH, here is radical, double bond and negative charge. And in presence of, so this basis is formed in presence of liquid ammonia, NH3, the negative charge takes the proton, there is NH2 minus, Again sodium transfer one electron. We see in the next step. So there is radical COOH. There is HH. Again sodium transfer one electron. There is formation of carbanion and carbanion HH double bond COOH. Carbanion takes the proton from the ammonia NH3 and there is loss of soda amide NaNH2 and formation of this 1,4 reduced product with COOH group present on saturated carbon system. Okay, so this is the mechanism for the Birch reductions. If there is electron withdrawing group present, only the COOH is an electron withdrawing group present in the Birch reductions. Now ester aldehyde ketone, these are electron withdrawing group, but before reduction of benzene ring 1,4 reductions, the carbonyl group reduced to CH2O minus. So let's see here the CHOH aldehyde group binds sodium in ammonia, liquid ammonia. This group reduced to CH2O minus, and this CH2O minus present on benzene ring is electron donating group, and as it is electron donating group, when the reductions of such a aromatic aldehyde or aromatic ester occur, then this aldehyde group ester group present on the unsaturated system, because these groups are reduced to CH2O minus, means it is electron donating group. It become electron donating group, and therefore only the COOH shows 1,4 reduction reaction in such a way that the COOH group is present at saturated carbon system. Okay, let's see the reductions of alkyne by using sodium in liquid ammonia. So alkyne C triple bond C CH3 CH3 Bu2Y and E by using sodium in liquid ammonia, it gives CH3 CH3 trans-but2-ene. So while this product is obtained as a major product, see here the mechanism of these reactions. CH3 C triple bond C CH3, again sodium transfer electron to unsaturated carbon, then there is migration of bond, that is formation of carbanion. The carbanion and electron present on are arranged in such a way that there is minimum repulsion between these two, and therefore they are oriented anti to each other, and therefore the methyl group get opposite to each other. Then by using liquid ammonia, the protonation, that is negative charge attack, here takes the proton, loss of soda amide CH3 CH double bond, there is CH3, here is one radical. Again another sodium transfer electron to this empty partially filled orbital, and there is negative charge from this side CH3 H CH3, and protonation by using liquid ammonia, there is protonation, again minus NaNH2, soda amide is lost, and there is formation of this anti, that is trans product is obtained by using these reactions. Now let's see another reduction by using sodium in liquid ammonia. There is reductive cleavage occur, for example in case of ethyl and chlorine. By using sodium in liquid ammonia, there is reductive cleavage, means carbon chlorine bond cleavage take place and formation of this product occur. Okay, So reductive cleavage takes place by using sodium in liquid ammonia. So these are the reductions by using sodium in alcohol and sodium in liquid ammonia. We will see the reduction by using magnesium, zinc in HCl, SnHCl or ApHCl in next video. Thank you.